NASA will soon add a new piece to its workhorse network of communications satellites with the launch of the TDRS-K spacecraft aboard a United Launch Alliance Atlas V rocket. TDRS is short for Tracking and Data Relay Satellite, and it continues to make a huge difference in the way astronauts and their spacecraft communicate with ground controllers. The first TDRS launched into orbit almost 30 years ago, when STS-6 astronauts deployed TDRS-1 from the Space Shuttle in April 1983. Before NASA launched its orbiting TDRS network, communications with spacecraft were sporadic, occurring only when the spacecraft passed near a ground station's antennas. With the space network in place, astronauts and ground controllers can talk to each other almost continuously. Just as important during this age of research in space, the TDRS satellites can convey round-the-clock data from automated experiments on the International Space Station to eager scientists looking for results. In addition, all of NASA's scientific spacecraft are built with communications gear that's compatible with the TDRS constellation so they can relay their observations to researchers. The Hubble Space Telescope images, along with all those taken by Earth observation spacecraft in low Earth orbit, go through a TDRS satellite before ground controllers and scientists receive them. Even a rocket ascending through the atmosphere during launch sends its telemetry through the TDRS network. This saves NASA the sometimes costly burden of having to maintain an array of ground stations, ships, and airplanes to communicate with a rocket in flight. The spacecraft launching from Cape Canaveral Air Force Station will be the 11th launch, but the first in about 10 years. It's also the first of the third-generation TDRS satellites. A United Launch Alliance rocket was chosen for this mission several years ago. Stacked at Launch Complex 41 at the Cape, the Atlas V is expected to add to its legacy as a strong and reliable booster.
We chose Atlas V as the ideal launch service for the TDRS-K mission because they had the 4-meter payload fairing capability, which is the ideal size requirement for TDRS-K, and also the performance capability of the 401 version of an Atlas V rocket with no solid rocket motors is ideally suited for the 7,600-pound mass of a TDRS-K satellite going to geosynchronous orbit.
The TDRS satellite's solar arrays and signature communications antennas are folded tightly for launch. Once safely in space, the TDRS will deploy its antennas and solar arrays and begin a 3-month series of tests and calibration.
Their antennas are furled, they come furled, and they have a margin, a certain amount of days that they can stay furled. If they pass that margin, then the antenna, when they're deployed, they can actually have a degradation in space. And so it was really challenging trying to schedule the shipping of the spacecraft with the launch date that kept coming and changing. It was very dynamic.
Engineers also tracked the rocket's progress closely and had to perform more analysis after an engine similar to that used on the Atlas V Centaur upper stage suffered an issue during a launch last year on a different rocket. The launch team does not expect a similar complication with the TDRS-K mission.
Our engineers and analysts from Launch Services Program, working alongside United Launch Alliance's engineers, we've been methodically reviewing data and have been working very closely on flight clearance for the TDRS-K mission. So that's been our biggest challenge to date.
The spacecraft will operate high above the planet in an orbit whose speed matches the rotation of the Earth exactly, allowing the satellite to appear to hover over the planet. From there, it can look down on a vast portion of the planet and offer direct communication between the International Space Station, numerous NASA satellites orbiting Earth, and the ground stations.
So all of the communication coming out of Space Station goes through the TDRS network and is downlinked to the Earth through TDRS satellites. So we're looking forward to add to that capability and continue a robust communications capability for NASA.
Though they provide a critical element for modern life on Earth, communication satellites sometimes are overlooked when it comes to the importance of spacecraft.
And I think, a lot of people maybe take it for granted. They don't realize or understand how many communication satellites it takes and all the work that's involved in order to get and the progress that we make here on Earth with all the technology that we have out in space.
Beyond its utility as a communications hub, The TDRS-K satellite, like all missions, makes a special place in the memory of the launch team sending it into orbit.
Every mission's got its own uniqueness. I mean, they're all unique. Nothing is ever easy. Oh, when we're counting down to launch, I think is the most exciting. You know, going into the terminal count, coming out of that last hold is always the most exciting. That's where the anxiety builds, and you're just ready to go, and until it launches. That's the best part of the whole launch day.